So this assignment is related to the topic momentum. I have solved the first 12 questions. So after that session, I will share the recording with you. Question 13, figure 2.1 shows a dummy of mass 70 kilogram. So the mass of this dummy is 70 kilogram. Used in a car, the crash test to investigate the safety of a new car. The windscreen, the passenger compartment in the dummy, the barrier is shown. The car approaches a solid barrier at a speed of 20 meters per second. It crashes into a barrier and stops suddenly. The momentum of a dummy immediately before the crash. So if the car is moving at a 20 meter per second, the dummy also move with the same speed as it's inside the car. So the speed of the car is 20, so it means the speed meter per second, speed of dummy is also 20. We want the momentum before the crash. So momentum is a product of mass and velocity. So mass of a dummy is given 70 and the velocity at which it was moving, that's 20. So it will be 70 multiplied by 20, which is equals to 1400, and the unit of the momentum is kilogram meter per second. Determine the impulse. We need impulse that must be applied for a to dummy to bring it to rest. Like what should be the change in momentum if you want to stop this dummy? So we want the final momentum to be 0. So what is the initial momentum? Initial momentum is 1400. Final momentum we want 0. Impulse is a change in momentum. So impulse is equals to the final momentum minus the initial momentum. The final momentum is 0. The initial momentum is 1400. So impulse is equals to minus 1400 Newton second. Why we have a negative impulse here? It shows that the direction in which we should apply the force should be opposite to the direction of the motion so that this dummy will stop. So you may have an impulse positive and negative. It does not make difference. It just evidence or give an idea about the direction of the change. In a crash crash, the passenger compartment comes to rest in 0.2 seconds. Calculate the deceleration of the passenger compartment. So how we can work out the deceleration or acceleration, that is the change in velocity divided by time. So it's V minus U over T. Initially, the passenger compartment was moving with speed of 20. Finally, we stopped and it took 0.2 seconds. So it will be minus 20 divided by 0.2. So which is equals to minus or negative 100. It's already deceleration, so we don't have to specify negative sign. We can simply say meter per second, 100 meter per second square, or ms minus 2. The seat belts in the airbags bring the dummy to rest so that it does not hit the windscreen. The dummy has an average deceleration of 80. Calculate the average resultant force applied on the dummy. So we have the formula, the resultant force is equals to ma, and the mass is 70, and the average deceleration is, why we took negative, because it's a deceleration. So we took negative. So it will be 5,600, but negative 5,600 Newton. That's the average, like the force which this dummy will experience. That the deceleration of a dummy is less than deceleration of the passenger compartment. Explain why this is a benefit for the safety of the passenger. Because if smaller deceleration, smaller resultant force will act on the passenger. As a result, it will cause like will reduce the chance of the serious injury or won't be fatal. In question 14, figure 2.1 shows two railway trucks on a track. So before they hit each other, the truck A has a mass of 6,000, which is moving at a speed of 5, then approaches a truck B, which is stationary. Calculate the momentum of truck A. So momentum is a product of mass and velocity. So 6,000 into 5, that's equal to 30,000. So 30,000 kilogram meter per second. The trucks collide and their buffer compress. They bounce off each other undamaged. After the collision, the truck B has a momentum of 27,000 kilograms. Determine the impulse. We need a change in momentum. So initially, the truck B was having a zero momentum. Then finally, when they hit each other, they bounce off, like truck A and truck B move in opposite direction. So this one is 27,000. So what is the impulse? Initial is 0, final is 27,000. So impulse is a change in momentum, so 27,000 minus 0. So the impulse, which is equals to change in momentum. So final momentum 27,000 and the initial momentum is 0. That's why it is 27,000 and the unit of impulse is Newton second. The trucks are in contact for a 0.6 second. We need average force. So we have the impulse, we have the time, the relation that impulse is force multiplied by time. So we need average force. It will be impulse divided by time. The impulse is equals to 27,000 and the time is equals to 0.6. That will give us the average force experienced by truck B when they collide with each other, which is 45,000 newtons. Calculate the final speed of truck A. So according to principle of conservation of momentum, the total momentum before is equals to total momentum after. So we were having truck B. Before the collision, it was stationary. So what is the momentum? That's 0 kilogram meter per second. Then we were having truck A, which was having a mass of 6,000 and it was moving towards the truck B. So mass is 6,000 and the speed at which it was moving, that was 5, so 6,000 into 5. So the total momentum was 30,000 before they collide with each other. That's the before collision. Then when they collide with each other, they bounce back. Truck B moved towards the opposite direction. So truck B moved towards left and truck A moved towards right. So the momentum of a truck B after it was 27,000. We need the speed. So before finding the speed, we should have the momentum of truck A. This is after. So this was 27,000 and the momentum of truck A example is X. So the total momentum before must be equal to total momentum after. So before collision, before they collide, it was 30,000. After the collision, it is 27,000 plus X. This will move. And what about this X? We should take as negative. Why we should take as negative? Because they bounce back. So it should be negative. So it will be 27,000 plus minus X. If we need X, so X is equals to 27,000. Like X move other side, 30,000 move to opposite. So it will be 30,000. It's equal to minus 3,000. This is the momentum, but we don't need momentum. We need the velocity. So momentum is a product of mass into velocity. That's equal to minus 3,000. Mass of truck B, which is 5,000 kilogram. sorry, mass of truck A, because we are finding for truck A, so I should take truck A. Truck A is 6,000 kg. So mass of truck A is 6,000 and the final momentum is minus 3,000. So V is equals to minus 3,000 divided by 6,000, which is equals to minus 0.5, which shows that it move opposite direction as the original one. That's why we are getting a negative answer.